Hello, and welcome to our lecture on the wage structure in Chapter 7. So today we're going to look at the distribution of wages. So of course some people or some workers will earn more than others, and there are reasons for that. There are productivity differences, there are differences in the returns to skills, and we also learn too compensating wage differentials as well. The point of this chapter is to look at the factors that contribute to the shape of the overall wage distribution, which we can see here. So here we have weekly earnings on the horizontal axis, and then we have the percentage of the population that has those earnings. So here we can see clearly that the wage distribution is positively skewed. There's a very long right tail. So there's a small percentage of workers who earn disproportionately large share of the rewards to work. And of course, wage differentials are going to exist because human capital investments vary from worker to worker. People have different preferences for what they want to study, what skills they want to learn. There are also age differences. So when we're looking at the wage distribution, the lower wages would typically be for younger workers. Older workers earn more, and so they have larger workers. Young workers are still accumulating human capital, and older workers are collecting returns from earlier investments. We see, though, that the positive correlation between ability and human capital investments stretches out wages in the population. And that's not surprising if you remember our internal rate of return discussions in the last lecture. We can clearly see that those of high and low ability are going to get different levels of human capital or schooling. Here we just, in this example, if we have different ability workers, so in the first line here represents a worker with low ability, then we could say maybe medium ability in the middle, and high ability. If they're all facing the same market or discount rate, they're going to get different levels of human capital, and they're going to get higher wages, and so this is going to stretch out the wage distribution. Now, how do we measure inequality? So inequality in terms of wages. Well, there's two concepts we need to learn, the Lorenz Curve and the Gini Coefficient. The Lorenz Curve is simply a curve that shows the distribution of income in an economy. It's a graph that shows the cumulative distribution of income for households categorized into 5 groups based on their income levels. You can think of lining up the entire population from the poorest to the richest. So each person has a certain income. You line them up from the poorest to the richest, and then you divide the line up into 5 equal segments. Okay, and in each of those segments, you're going to have a average earnings, and we'll do something like this. So here you can see the share of the households on the bottom, and we have a line from A to B, and this is called the perfect equality Lorenz curve. So if everyone had the same level of earnings, then as we go along here, we would get just a perfectly straight line. So the first 20% share of households are going to have 20% of the income. The next 40% are going to have 40% because they all would have the same income. Okay, so this would represent an economy with perfect equality. Everyone has the same wages. Now, underneath would be an example of an actual Lorenz curve. Okay, and so here we see that the first 20% or the first 20% of households has much less than 20%, a 20% share of income. And then if we look at the 40%, the first 40% of households, they still have less than 20% share of income. And then we can start seeing this is getting steeper. So when we look at the last 20% of people, the share of income goes from roughly 0.5 all the way to 1. Okay, so this describes the actual income distribution in the economy, and the Gini coefficient is just the ratio of the shaded area to the triangle ABC. And so the larger the number, the more inequality there is. And if you can see, this is only going to be between 0 and 1, the Gini coefficient. Okay? If there's perfect equality, then you're going to have 0 divided by this whole area here. But as we get more and more inequality, this shaded area increases. Okay, so if you want to think of, well, let's look at another diagram in a moment, and it will be a little more clear. First, let's think about a Canadian example. So here we have different years. We have our 5 different groups. Okay, again, think of taking all the people in the population and making a straight line with the poorest person at the beginning of the line and the richest at the end. And then taking that line and dividing into 5 categories. So if we do that, we'll get something like this. And we can see here, you can ignore this line. This line here, I'll fix that for you. This line should be here. Okay, so we have our 5 different groups. In 1961, the lowest 20% of the income earners only had a 4% share of the total income. So that you could think of that as like they only had a 4% share of the economic pie, the overall economy's wealth. Whereas the last 20%, they have 44% of the overall wealth. And if we look at this over time, we see that they've varied, but consistently the group of households with the highest income received over 40% of the total income, and then the lowest group has 5 or less percent of the total income. These are the average earnings within each category, and the average of the total 7,500. So if we were to construct a Lorenz curve out of this, we would simply plot these values. So the first 20% of households, that's this group here, their share of income is 4%. Okay? So that's 4%. We plot that there. Now, the next group, their share is 10%. So we would put that there. And sorry, it's important to point out that we're plotting the cumulative share of income. Okay, so the second group represents 10% of the overall income. So that's their share of total income, but we're plotting the cumulative share. So for the lowest 40%, the cumulative share is the 4 plus the 10. So it's actually 14. So this point B is 14. When we plot the 6 for this up to the 60th, that's going to be 29 because we're going to add 15 plus 14. We get that point. The last point is E, and that's for the last group. So at 100% of households, when we get to this point, so we're going from 80% to 100%, their share of income is 47%. Okay, and we're adding, it's a cumulative share, so when we get to this point, we've taken into account all of the households. Okay, again, this line here would represent perfect equality. Okay, because the first 20%, if everyone has the same income, the first 20% of households would have 20% of the income. The next 20% would have, another 20% of the income, so it would be 40. Um, if you had perfect inequality, so perfect inequality would be one person has all of the income. So if you think of our line of people, we would have zeros all the way up to the last person. Okay, and so we would have all zeros, and then the last person would have 100% of the wealth. Okay, so again, the Lorenz curve is this line here, and the Gini coefficient is the ratio of this area to the whole right-sided triangle here. Okay, so the Lorenz curve as is a useful measure of the distribution of income. It's useful to compare to economies. Suppose in an economy, or we already know this, in an economy of perfect equality, we would have the Lorenz curve being just a 45-degree line. And in an economy of perfect inequality, we would just have the vertical line, as I mentioned. So the Gini coefficient is very useful because it's a single number that tells you about the level of inequality in a country. And again, the Gini coefficient is this region as a proportion of this whole right-angled triangle. Okay, so it's equal to A over A plus B. And so that means it's going to range from 0 to 1. 0 means perfect equality, and 1 would mean perfect inequality. Now, there's other measures of inequality. We can look at the wage ratios between different percentiles in the distribution. So one example would be the 90-10 wage gap, and that's the difference in the 90th and 10th percentiles as a percentage of the 10th percentile wage. So it would be the difference divided by the wage in the 10th percentile. The 50-10 wage gap is the difference in the 50th and 10 percentiles as a percent of the 10th percentile wage. So similar, but now you would just use the 50th percentile wage. Now, the wage gap between those at the top of the wage distribution and those at the bottom has widened dramatically since the 1980s. Some of this is potentially due to differences in education, and we've also seen a widening among education groups, experience groups, and age groups. And we've also seen increases in the differences in demographic and skill groups. So let's look at some data. So this is from roughly mid-1930s to 2005, and this is the Gini coefficient. And so we see that it was, we went from an area where if we look at all workers, it was quite, the Gini coefficient was quite high, so it was measuring a lot of inequality. That seemed to fall over the 40s and 50s, and roughly the mid 50s or early 50s to the 70s, it was roughly constant, and then it has skyrocketed since. So it was roughly stable until about 1970. From 1950, and then it has increased a lot since, and it's increased for women, men, and then of course when you combine them. Now, this chart here is the 80-50 wage gap, and so we can see that much of the increase in the Gini coefficient in the past 30 years was due to a widening of the 80-50 wage gap. Okay, so this is stretching out the income at the upper end of the distribution. So that's mainly responsible for the increase in inequality. People in the lower end of the distribution, there's not much going on there. It's you getting the stretching out effect on the right hand of the distribution. And here is the 50-20 wage gap. So we can see here we didn't get significant increases in that compared to when we look at the 80-50 wage gap. Now, the increase in wage inequality can be directly attributed to sizable increase in the returns to schooling. So here we have a chart of the wage differential between college graduates and high school graduates from 1963 to 2005, and we can see that this difference has increased substantially. So what could have caused this? Well, the demand for skilled workers increased relatively more than the demand for unskilled workers. We're going there as a proportion of the labor force, there's less manufacturing, there's more jobs in computers, networking, a lot of jobs that require education. There's also increased physical capital in manufacturing firms that is used to increase the productivity of skilled workers, not unskilled workers. And there's a decrease in the supply of skilled workers or an increase in the demand for skilled workers. So, I mean, of course, a decrease in the supply or an increase in the demand could cause a widening of the gap. Now, let's look at a diagram to sort of get a feel for this. Changes in the wage structure from shifts in supply and demand. So we're going to think about shifts in supply and demand and how that could affect the wage gap. So we have a downward sloping demand curve. Okay, so this is a labor demand curve. Okay, so employers wish to hire relatively fewer skilled workers when the relative wage of skilled workers is high. So it's useful to point out that on the vertical axis here, we're measuring the relative wage of skilled workers. Okay, so the higher this value is, it means the higher the wage is relative to unskilled workers. Okay, and so obviously it's downward sloping because the higher the relative wage, the less the firms would want to hire. We are going to represent the supply with perfectly inelastic supply curves. So that indicates that the relative number of skilled workers is fixed. So we're just going to assume they're fixed. And let's assume the initial equilibrium is at point A. And let's suppose that the relative supply of skilled workers increases to S1. Well, if the relative supply of skilled workers increases, that will shift it to the right. Okay, and if we're on the demand curve D0, that would result in the relative wage falling. But so, I mean, you can only have that the wage is increasing if at the same time there's a sizable outward shift in the relative demand from D0 to D1. So this shift would have to be larger than this shift in order for the relative wage of skilled workers to be. There's a number of other reasons too as to why wage inequality increased. There's supply shifts. International trade is also responsible. Skill bias technological change. Institutional changes in the U.S. labor market. So there's been less unions. Minimum wage hasn't increased as much. When talking about the wage distribution, one thing that comes to mind is the observation that some people make extremely large sums of money within the same job. So this is called the superstar phenomenon. So some professions, some people in certain professions dominate their field, and their income is, a multitude higher than the average. So, for example, movie stars, sports players, you have the exact same job, but just because they're, different people in that job mean much different wages. And, it's not that surprising. What's going on here is that you have only a few sellers have the exceptional ability to produce quality goods or talent or singing very good, that we demand we demand a very large, if you think of top actors, the demand to see them is very, very large, and people are willing to pay a very large premium. So it's, there's some people with talents that are very, very scarce, and the demand to see that scarce talent is very, very high. And so, of course, then the income for those people are going to be very, very high as well. Um, Now, what about inequality across generations? So we find a positive correlation between the skills of parents and their children. High income parents typically invest more in education of their children, and this is higher than what low income parents would do. So there's a tendency for income differences across families to get smaller over time, or regression towards the mean. So if we look here on this diagram, we have education of children and education of parents. Okay, if the slope of if we were to plot the data and run a regression, and the slope of that regression line was equal to 1, that would mean that it would imply that the earnings gap between any two parents, okay, the earnings gap between any two parents, their children's income will also differ by 1,000. And so there'd be no regression towards the mean. However, if, say, the correlation were equal to 0.5, so this would be somewhere between 0 and 1, then the a $1,000 earnings gaps between the two parents translates into a $500 earnings gap between their children. And if the slope equals 0, the wage of children is independent of the wage of parents, and there would be complete regression towards the mean. So let's do some questions to reinforce the material. Suppose we have a hypothetical country called Libra. There are 5 households with annual incomes of $5,000, $10,000, $15,000, $30,000, and $40,000. So we're asked to calculate the shares of total income earned by each household. Okay. We're also asked, what are the cumulative shares of income earned by each household that would be used to draw this country's Lorenz curve, ranked from the lowest to the highest? And we're asked to draw the Lorenz curve. Okay, so maybe you should pause the lecture and work this out on paper before looking at the answer. Okay, so let's look at the answer. So in A, what we're going to do is have our 5 categories outlined here. The annual income in each of these categories is $5,000, $10,000, $15,000, $30,000, and $40,000. And we were told that in the question. And the share of income is obtained just by taking this and dividing it by the total income. Okay, so the total income is 100,000. So we're just going to add them together and then take the annual income in that category and divide it by 100,000 for each. Okay, so we'll get 5%, 10%, 15, 30, and 40. And then we can do the cumulative share of income. And so that's obtained just by summing these up. So this figure is obtained from adding this plus this. This is from this plus this plus this. And we have our cumulative share of income. So the Lorenz curve is just a plot of those cumulative shares. So here we plot the Lorenz curve, and it will look like this. So the first 20% of households, their income share is 5%. The second group contributes 10, but we're adding them together because it's a cumulative share, and so that's 15. So the second figure is 15, and so if we wanted to calculate the Gini coefficient, we would find out what this area is and divide it by the area of the right angle triangle. Okay, next question. If incomes rise for both low income and high income workers, but rise less for the high income workers, which one of the following is true? Okay, I'll let you pause the video, think about it. Okay, well, the answer will be D. Then poverty will fall and inequality will fall also. So we have lower income workers, their incomes are increasing more than the higher income workers, so of course things are becoming more equal. Wage differentials across individual workers are determined in part by, what's the correct answer here? Effort, productivity, social capital, luck, or is the answer all of the above? Of course, here the answer is all of the above. The positive correlation between ability and human capital investment stretches out wages in the population, generating what? Okay, take a look. What do you think is the correct answer? Perhaps pause the video. Okay, so at the beginning of the lecture, we know that the answer is a positively skewed wage distribution. This means there's a long tail to the right. Which of the following measures would best allow one to compare the relative wealth of poor households to the typical household in an economy? Okay, so we want to compare the relative wealth of poor households to the typical household in an economy. Which one of these would it be? Okay, the answer is D, the 50-10 wage gap, because we're looking at the center compared to the lowest 10%. And so thank you for listening. That concludes our lecture on the wage structure. Next class, we will be discussing labor market discrimination. Thank you for now, and we'll see you next time.